Hi, this video is about using the web files that came with your textbook for queuing analysis. So it assumes that you've read chapter 15, and if you can see here on my desktop I have the 5 models you have studied in your textbook, and we did 5 models: the single server model, the multiple server model, and that's the single server file, that's the multiple server, the finite population model, the no waiting model, the loss code, sometimes called the loss model, and the when you have non-exponential service times, called the arbitrary service time model. So we're going to start with the single. I'm going to do the single server model. So if you once you download the web files from your course website or from Blackboard, you just click on this file and you can see here. So this is the single server model where we have Poisson arrivals, we have exponential service times, and that's where your input, the only input you need is the arrival rate and the service rate, and then you get your operating characteristics or performance measures of the model, and you have your economic analysis. So once you open the file, you have a solved problem which assumes you have an arrival rate of 0.75 and a service rate of 1, and gives you all the characteristics. So all you need to do to solve any single server problem with Poisson arrivals and exponential service times is to change those two rates, and I will talk about economic analysis in a minute. So suppose I have a problem where my arrival rate, instead of being what's the arrival rate? The arrival rate is 1 over the mean, so you have to keep that in mind. If you are given the mean time between arrivals, you need to change that to a rate for this one to work. If you're given the mean service time, you need to take 1 over that, the reciprocal, to get the service rate. So this is number of customers arrived per unit time, and this is the how many customers are served per unit time. And the unit time should be the same. So if I had here an hour, this should be, I can't write here apparently. I need to enable editing for this to work. Yeah. So if I have an hour here, I should have this per hour. If it this minute, this should be minutes. So remember, if those numbers are given to you with different units, you need to make sure that they follow the same unit, right? So this doesn't have to be hours, can be any unit. So suppose my arrival rate is not really 0.75 but maybe 0.85. Just change it, enter, and then it gives you the new performance measures immediately. If you have the weighting, the cost analysis, when we do cost analysis, we do it with, there are 2 types of costs in your textbook. The weighting cost, how much it costs the system for a customer to be waiting, and let's say that's $5 here per unit time. And the service cost per channel, channel means server, so and suppose that's say $10, say maybe think about an hour minimum pay, whatever, and so that gives me the, so if I have multiple, in this case I can't have multiple channels because I only have 1 channel, but we'll talk about it when we have multiple service times. But now, so let me go back. So if I change my arrival rate to say 1.5, what would happen? Oh, I got negative numbers. That's because my arrival rate is higher, higher than my service rate, and my system is unstable, so I cannot have an analysis. Apparently Excel shouldn't give you values, but it gives you negative values. So that's an indication you have the system is unstable. So I have to, so if my arrival rate is 1.5, which means on average I have 1.5 customers arriving per minute, and the service of a customer, I can service on average 2 customers per minute when there are customers. So that's like a on average a customer takes half a minute to serve, right? Then I got those performance measures. So now this is the first one, is the P0, probability no customers are in the system, which is 25% of the time there are no customers in the system, which is the same as the probability that the server is idle, or it's 1 minus the utilization. So I know the server would be busy 75% of the time, or that's the server utilization in this case. There would be 2.25 customers on average waiting in queue, excluding the service time. There would be 3 customers on average in the system, including the one in service. And the average time to wait in queue, 1.5 minutes. That's before you start service. 2 minutes, including the service time. And that's the probability of having to wait. So if you arrive at this system, what's the probability you have to wait? It's 0.75. That's the probability you don't have to wait. If the system is empty, you go and you enter immediately. And that's the cost per minute or per unit of time for the system, taking into account both the cost of providing the service and the cost of having customers to wait, being delayed. So that's basically how this model works and how all other models work. So let's go and look at other models quickly. So if I go to, say, this is single server, this is again single server but an arbitrary system, and the only difference, we have to enable editing here, is that I need the service rate and I need the standard deviation. So this usually would be given the mean and the standard deviation of the distribution, which can be anything. The performance measures are the same. You can enter the waiting costs, any numbers here, whatever is given, and you can see, get those values. If my service rate, it changes, say, to 0.6, then all my performance measures change. Okay. Do another model quickly. And say, now let's look at the finite model. So here I have, in this case I have Poisson arrivals, exponential service times. I have finite calling population, like I have machines maybe that need to be repaired. I don't have infinitely many of them. I only have, in this case, 6 of them. I have 2 servers, 2 repair person. The arrival rate, that's per unit. So each unit breaks down when it's active, when it's up, when it's functioning at this rate, and this is how long it takes to fix it. So maybe this is in days here. It takes half a day, 2 days to fix the machine, maybe, and 0.05 to break 1 over 0.05, 20 days on average for a machine to break down. And this would be the operating characteristics, and same thing, we can calculate, do the cost analysis. So if I change this to, say, if I have 8 machines instead of 6, click here. Oh, what happened here? Oh, I didn't enable content here. Oh, yeah, sometimes you have to both enable editing and enable content. So I got those values. If I have any values here for service and cost, I have this one here. And in this case, actually, if I change this to, if I have 3 servers now, you can see that's how it's going to change my cost also, because now I have each server cost $5, and all the performance measures change. Okay, one more. Let's do another model. The multiple server model, and this, I tried this before, enable, and you notice here you lose the values here for some reason. It doesn't work, but I figured out a way to fix it, where you go to formulas. If in your system it didn't work, I have to click here on P0 fx. That's the 2 here, and click OK, and now I got those values. Now I can change this. So if my waiting cost is 6 and cost per server is 7, my cost is 1947. So if 1924. So if I have 3 servers, where is it? That's gonna change my cost here, and also changes all my performance measures. So I can compare costs of different systems. Again, P0, that means all servers are idle. LQ, how many in the queue, how many in the system, how many waiting in the queue, how many waiting, including service time in the system. And that's the probability of a customer enters the system. Sorry, that's the probability that a customer has to wait, which means all 3 servers are busy in this case. Okay. So if I change this to 4, and you can see now I got a system which is unstable. So if I change this to 2.5, now I got some reasonable numbers. And so on. There's another model, one more model I want to quickly go over, which is the no waiting. This is a model now, no waiting model. Poisson arrivals. It can be exponential or any service time, because in this case the formulas are the same. So I have number of servers are 4, arrival rate 12, service rate is per server is 6, and you can see that you get all these results. All you have to do is change if you enable editing. Oops, you get the same problem. Enable content. Yeah, that works now. So I can make changes here in my input and get the corresponding output there and do the economic analysis. So these are the models we have here. What happened here? Thank you. Thank you. And